So you have your protractors and your compasses, your distance copiers. So, for example, segment LM might be congruent to, not a real thing, segment, I know DG is not one on there. DG. Okay. This little symbol means congruent. Have you guys seen that yet? Oh yeah, we saw it because like equality is for measures and congruence is for figures. We did that at the end of our last notes. Okay, I mean, this is not true because these don't exist on your page, but like, find the ones that match up. So I want you to make me a list of segments that are congruent. You can cross them off as you use them. I think you only use them once. Okay, go. Okay, we're just checking the answers with mine to make sure that we did it right and that I did it right. Did I make any mistakes? No. Okay. Okay, any questions about how to do that? Okay. So a couple of things. Whoop, 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 whoop. All right, so on this one, a couple of things that we need to talk about. So this is still on the front of your paper. Don't flip yet. This is some notes about notation. Okay, AB with a fun little line over it is a segment. Okay, if I say the measure of AB, or if I just say AB, the letters, that is the length. Okay, so can you guys give me one of the congruent pairs? What was AB congruent to?
QR.
Okay, so AB was congruent to QR. Make sure that you have the segment bars over both of those. If you measured those with the rulers, what is the same about their measures? Well, I kind of said the answer, didn't I? The measures are the same, right? Their lengths are the same. So I can say that the measure of AB is equal to the measure of QR, right? The figures are congruent, the measures are equal. Does everybody see that? Okay. Cool, cool, cool. All right, let's flip over to the angles. We're going to do the same thing with these angles. You're going to find their little angle buddies. Guys, when you're doing this, there's going to be a problem. A big problem. The big problem is that when you put your protractor on, oh shoot. When you put your protractor on here, like the numbers are going to be way out here, and your little angles, look, your little angles are going to have short little sides that aren't going to go all the way out. Okay? And we want to be very precise. So in order to be able to use the protractor on these, you're going to have to do what is called auxiliary lines. So an auxiliary line is where you take your straight edge and you extend like this. Remember, these are segments that are on rays, and the rays are infinite. They go on forever. You know what I'm talking about? Okay. So now I can take my protractor and line it up. And I can tell that this is exactly 44. Without knowing that it was 44, I might have guessed it was like 45 because it kind of looked like it was in the middle. But do you see that it's not? Okay? So when you're measuring, make sure that you are getting those auxiliary lines on there. You may use the ruler edge of your protractor to make your auxiliary lines go. Can we talk about angle C and angle E for just a second? So when I looked at these, do you see that the segments that make up the sides of the angles, like the ones for C have longer segments, right? Okay, but if I can extend it forever with auxiliary lines, does it matter if one has cute little stumpy segments and the other one has longer segments? I got 59 for both. Okay, well, we can talk about that in a minute. I guess my point is that it doesn't matter that these little segments on angle E were short and the ones on angle C were longer, because I can extend both of them infinitely, right? Because they're part of rays. So in order for the measures of these angles to be the same, did the segments have to be the same length? Correct, they did not. Okay, so when you're measuring or finding your congruent angle pairs, remember we talked about the interior of an angle as opposed to the exterior? What we're measuring is this rotation right here. And if that is the same size opening, it doesn't matter how long the segments are, because those segments are parts of infinitely long rays. Any questions about that? Okay. So a word about notation. We can say that angle C is congruent to angle E, right? Those are figures, they are congruent. If we're talking about their measures, we can say that the measure of angle C is equal to the measure of angle E. Congruence is for figures. Equality is for measures, which are numbers, right? Values. Everybody see the difference? Okay. Are you ready to check your answers, or do you need more time? Ready? Okay. Whoops, that's the front. Okay, these are the ones that. Okay, so it's A and J, B and L, angle C and angle E, angle D, angle F, angle H and angle N. Those are all the congruent pairs. How did you do? Before we go on to the next bit, I want to talk again about the front. Can we flip back to the front? Okay, so we said that AB, segment AB and segment QR were congruent. Did anyone measure those with the rulers? Check their measures with the rulers. What do you get with the rulers? Specifically AB and QR, because I already have those written on the board. What did you get? It doesn't matter. Someone can do inches, someone can do centimeters. Whatever you got, holler it out. 3.3 centimeters. And the other one is also the same. Did anyone use the distance copier, the compass, to see if they were the same? Okay. Did anyone measure them in inches? What did you get for inches?
1.5 and 1.5.
Okay, so 1.5 inches equals 1.5 inches. And then, did we have a unit for the compass? Do we have a unit specifically? Did the units matter? So regardless of the units, we could even pick our own arbitrary compass unit. They were the same measure. Everybody okay with that? Congruence is independent of the measure. Okay, just felt like we needed to say that. Okay, cool. All right, let's talk about some stuff for congruent figures. Okay, thinking about the line segments that you analyzed, what was the same about the segments? Did they have to have the same orientation in space? Like, could they go like this? Yeah. Okay, so they did not have to be oriented the same. What did have to be the same? Their measures had to be the same. Or like the setting on the compass, right? Okay, so we know that line segments are congruent if and only if they have the same measure. Measure is another word for length. Okay, do you guys see that if is spelled really weird? Okay, this is not a typo. It means if, write this down, and only if. Now, what that does is it gives us a statement that it gives us a promise that this statement is true backwards and forwards. So we can say that line segments are congruent if they have the same measure. We can also take segments that have the same measure, and then we can conclude that they are congruent. So if we know they're congruent, we say that they have the same measure. If we know they have the same measure, we can conclude that they are congruent. That is a very powerful tool. Okay, so we can also say that we know segments must have the same measure if they are congruent. It's true backwards and forwards. Not everything is. Okay, now think about the angles that we analyzed. How did we make sure that the certain angles were congruent? Did they have to have the same segment lengths on their sides? Okay. Oh, shoot, guys, I blew it. Gosh darn it. Okay, so we're going back and we're tracing angle C very, very carefully. Just on the paper somewhere. Angle C, yeah, because that's the one we've already kind of talked about. I definitely forgot about this part. I just gave you the protractors. You know how you got like the ruler and the compass for like copying distance? But I only gave you the protractor for measuring the angles. I was supposed to give you this like tracing paper, but I blew it because I suck at life sometimes. Did you just say true that?
No.
Okay, that's fair. I really just had one job, and I kind of failed a little bit. Okay, now that you have your angle traced, you can spin it around, do whatever you want. I want you to see what happens when you lay it over the top of angle E. What happens?
They're the same.
They're the same. So if I had given you a bunch of tracing paper, could you have figured out which of these angles were congruent?
Yes.
Okay? It does not matter their orientation in space. It does not matter how long their little segment sides are. Okay? If I can like slide or rotate or reflect and move the tracing paper from one to the other and get it to line up perfectly without bending or stretching, then I know that these angles are congruent. Everybody satisfied that that would have been really cool if I'd have remembered to do it? Okay, sorry. You can find the complaint box at the back of the room. It's blue. It's the recycling bin. It's a joke. Like I would.
We throw it away. We throw it away.
No, don't throw it away. All right, so think about the angles that we analyzed. How did we determine that certain angles were congruent? Well, we had to measure them, right? We used auxiliary lines and protractors. What else did we do after I remembered? Yeah. Okay, so two angles are congruent if one angle can be moved so that it coincides exactly with the other angle without bending or stretching either of the angles. Here, I'll move this up so you can see it. Could we have used the tracing paper on the segments, do you think? You want to try? You got room. You should have room.
Let's try.
Go ahead and try tracing one of the segments you know is congruent to another. Okay, so you can use the tracing definition on the segments. Okay, and we measured the angles, so we know that the measurement definition works for the angles, right? So we can use both of the definitions. They are both the same. Okay, this is very important. I know you're all getting twitchy, but I need everybody's eyes up on my face. Okay? So our two different definitions for congruence are the same. Either the measures are equal, or we can perform a series of transformations, like using tracing paper or whatever, to line up the angles or segments exactly with the other segment or angle, right? All right, so that's what we're going to make. I want you to try to put these definitions together and make one massive definition for congruence. That's why I gave you all that room at the bottom of the page. Okay, if you're stuck, you can look at mine. I want you to try it yourself, though. Try it yourself. Write a little paragraph. You're making one massive definition. Try to do it in your own words. Go.